Hello, good morning, everybody. I am Shimon Hochbaum. I'm product management in Siklu out of our office in Israel, and I will be the host for this webinar. There will be about 15 slides today, followed by a Q&A session. You can use the chat window on the right of your screen to send me questions to which I will respond during the Q&A session. We are launching today our fastest fiber-like wireless product, the EH5500FD, a 5 gigabit full duplex E-band radio, and like any fiber link which plugs directly into aggregation or edge devices, our EH5500FD is designed exactly for the same purpose. A single SFP Plus socket handles the traffic in and out of the radio and plugs via standard SFP Plus transceiver to any length of optical fiber, short or medium range, to the aggregation or edge devices, an Ethernet switch, a router, or a demarcation device, whatever is the normal practice in your network. And as this is a little bit of departure from our other ODUs, which have more than one port, I wanted to draw attention to that a little bit right away. A single port, because after all, we have designed this EH5500 to simply replace fiber. So let's start now with some details about the product. The 5500FD works across the E-band, and in order to deliver 5 gigabit, we have a channel bandwidth of 1250 megahertz, which makes for 3 channels available across the 71 to 76 and 8186 gigahertz spectrum. The product will ship with a basic rate of 2 gigabit full duplex and can be upgraded via a software license to 5 gigabit. And because we have designed the product to be as close to fiber as possible, the latency is typically around 5 microseconds. Otherwise, we retain many of the attributes of our standard platform, which is field proven with an MTBF of 90 years. So we will have a choice of DC power or power over Ethernet power. The alignment is still simple with a DVM and no other tools. And RJ45 interface is available for management and power over Ethernet. The SFP Plus socket is for the traffic itself. Pay attention to that. We have been using so far SFP sockets in our products, which are capable of 1 gigabit traffic. And now that we want to go to 5 gigabit payload, we need to upgrade to SFP Plus sockets, and we'll come back to that a little later. We retain also the same form factor of our existing large ODUs, which allows to use right away the same antennas, the same mounting kits. So we have antennas starting at half a foot and 38 dBi gain in a slim form factor, which allows deployment in the street or anywhere the ODU has to be discrete. Please note, however, that the 38 dBi antennas are not approved for use in the US. We also offer the 1 foot antenna with 43 dBi gain and the 2 feet antenna with 50 dBi gain. The mounting kit covers both the 1 foot antenna, while for the 2 feet antenna, the mounting kit is built into the antenna. I told you earlier that we need to work with SFP Plus transceivers now. We have Siklu will provide a choice of 2 transceivers for short or medium reach, or basically for multi-mode or single-mode fiber, depending on what is typically used in your networks. And we have also started to build a compatibility list with third-party devices, which we will expand as necessary. The compatibility information will be available on our partners portal. If we consider the management, I told you earlier that the RJ45 port is there for management, and we illustrate here how this is normally affected. So the EH5500 is managed out of band. The RJ45 port is the management port, and the IP address of the ODU is mapped to this port, not to the SFP+. This means that the same aggregation or edge device into which the ODU plugs has to split the management VLAN away from the traffic and connect the management traffic to the copper link which connects to the ODU. From there, when this connection is physically established, all management tools are available, the web GUI, the CLI, SNMP, access to the MIB, etc. And when the web GUI is used for management, we can of course see both sides of the link. The local ODU via this arrangement and the breakout of the VLAN, and then the remote ODU by means of the overhead management channel which is established between the two ODUs. Another departure from what we do normally with our ODUs is the flow control. The optical link between the Ethernet device runs at 10 gigabit per second, while the radio is only capable of 5 gigabit per second. So what happens when the traffic sent by the Ethernet device peaks higher than 5 gigabits, or if there is a strong rain event which takes the modulation down to 2 gigabit or lower? In order to overcome these circumstances, the 5500 uses standard Ethernet pause frame to signal to the local device that it is overloaded. Let's see how this works. So first we'll put here a timeline of events. We have some packets arriving to the ODU, and while the receive buffers in the ODUs are not full, all is good and processes normally. If we now have a burst of packets which arrive very fast and basically fill up the receive buffers in the ODU, then the ODU immediately will respond with a pause frame and an indication for how long the device should stop sending traffic. The device, the Ethernet device, will now start discarding traffic per its policies and will wait for expiration of the timer. During this time, the buffers on the receive side of the ODU are going to empty, and when the timer has expired, the Ethernet device will resume sending traffic to the ODU. That's a very simple and standard mechanism to flow control traffic on an Ethernet link. A side benefit of this behavior is that the thresholds and the discards are now programmed into the single device, the Ethernet edge or aggregation device which is connected to the ODU. This will simplify greatly traffic management processes and engineering inside your network. A little bit about the performance of the radio. The system gain with QAM32 is 71 dB and delivers 5 gigabits. This does not include the antenna gain. In case of rain event, we can drop the modulation to BPSK and the system gain will improve to 93 dBi to maintain the link. Here below we illustrate some rich capabilities with the different antennas, assuming a range zone K and 99.9% availability. 3 kilometer with the 1 foot antenna and 5 kilometer with the 2 feet antenna. If you want to calculate some other configurations, you can refer to the link budget calculator that Siklu provides, and the 5500 with the different antenna configurations and range zones is available there. Let's talk now about some typical applications of the 5500. The simplest case obviously is a point-to-point link from an aggregation site to a served building, where fiber is not available and one wants to deliver more than 2 gigabit of full duplex traffic. A very simple configuration. Another configuration is where the same building may already be served now by fiber, but some of the tenants want redundant access from the building to the network of the service provider. If fiber is difficult to get into the building, we know that wireless fiber is a lot faster to deploy, and this way the tenants can be connected with redundant facilities into the building. Other types of application are radio rings, where we may need a higher capacity than what we have been deploying so far, especially when there are subtended rings of the main ring and we want to run a lot of traffic from there. So a complete fiber ring, a complete radio ring, sorry, can now run at 5 gigabit full duplex. And another configuration, or another typical application, sorry, could be where the service provider is trying to run a fiber ring, but there is some obstacle which makes it very difficult to close the ring, for example, across a railway or some highway. In that case, closing the fiber ring with the EH5500 wireless link would be very simple. So to review what we have been talking so far, I'd like to highlight some of the key points. The EH5500 is even more fiber-like wireless than what we have done so far, with a capacity of 5 gigabit full duplex. Like any fiber link, it connects always to an aggregation or edge device, and all this comes in the familiar Siklu physical package, which means that it offers the same choice of antennas, mounting kits, and there is no need to retrain or carry special inventory of accessories to start integrating the 5500 in your network. And I will now turn over to the Q&A session. Okay, so one of the first questions which I see coming here is, are we talking about a FDD or TDD device. The EH5500 is an FDD, so we are running a transmit and a receive channel in parallel out of each and every ODU to the other side of the link. It is therefore an FDD or a full duplex device. 5 gigabits are available in each direction of the link. Another question which was asked is the bandwidth of the half-foot antenna. So in those countries where it is allowed to deploy a half-a-foot antenna, which comes with a 38 dBi gain, the bandwidth is still going to be 5 gigabit full duplex. The reach will be obviously a little smaller since the link budget will be reduced compared to the 1 foot or the 2 feet antenna. Another question is, can we do CPRI across such a link? Again, this is an Ethernet product. It can only carry Ethernet traffic and it cannot carry CPRI on this product. Another question is, are we using 70 and 80 gigahertz? The answer is yes. One direction of the link is in the 70 gigahertz band and the other direction of the link is in the 80 gigahertz band. So we use 2 channels if you want, or 2 portions of the spectrum for each and every link. We can run a number of links in parallel from the same base to different directions. We have 3 frequencies or 3 channels if you want that we can start using, and then we can also use the other polarity, so you can run 3 links in vertical polarity and then the 3 other links in a different polarities, and you can this way run a number of links in the base. Remember also that the antennas that we use are relatively narrow, 1 degree or half a degree, so we can use a number of tools in a bag of tricks to run more than 1 link out of the same base. I have a question here where somebody is asking whether we can run 5 gigabit on one of the channels, or do we need more than 1 channel to do this? So very clearly, one of the 3 channels is enough to run the 5 gigabit. Each channel is 1250 megahertz and can carry the full 5 gigabit full duplex in this way. Another question, do the radios automatically modulate down during a weather event? The answer is yes. That's a standard practice at Siklu. We have an automatic control of the modulation, the channel bandwidth, in order to maintain the needed quality of the signal on the receive side. The 2 radios coordinate all the time, constantly, to maintain link availability in case of a weather event. This can cause the throughput to go down, like we do with all other radios, and when the link goes down while the traffic does not, as I explained before, the 5500 will signal to the Ethernet device that it has to pause using the standard Ethernet flow control. The 5500 is available now. Some units have already shipped, and we welcome additional orders if you have some. The 5500 will ship out of the box with a 2 gigabit rate, and it is software upgradable to 5 gigabits. So basic configuration is 2. There is a single software license to upgrade to 5, and that is the only software license that you ever need on the 5500. The power consumption of the 5500 is 45 watt. This can be delivered with direct DC, starting with a range of 36 volt to 50 and some volt direct DC, or you can also use PoE AT plus. We need 45 watts, so that's above the regular AT standard, and we need 4 pairs on the Ethernet cable to deliver 45 watts. Another question about the impact of using horizontal or vertical polarity on the loss. No, there is no noticeable difference. The link budget capability will be the same regardless of the polarity used on the link. Another question here about the upgrade, say from an existing 22 or 2500, the 2 gigabit full duplex ODU to the 5 gigabit, because we use the same antennas, the same antenna interfaces between the ODU and the antennas. So if you have a 1 gigabit, if you have a 1 foot antenna or a 2 feet antenna, you can swap the existing ODU 2225 or even a 1200 ODU as long as the antenna is detachable from the 1200 or 2200 to a 5500, just a replacement of the ODU on both sides. Obviously, if you are not running fiber, you have to run the fiber cable and plug in the SFP Plus transceiver on both sides of the fiber. But other than that, the upgrade is very simple. And somebody wanted to see the link budget calculator, so I'm going to go quiet here for a minute until I get my screen up to the link budget calculator. 1 second, please. So you can see now the link budget calculator from Siklu. It's already opened on the 5500 FD. The channel bandwidth is set for 1250. You can select your center frequencies, the types of antenna that you would like to use from 38 all the way to 50 dBi or half a foot to 2 feet. You can select the rain zone and then enter the other parameters, and you have here an example of what happens at 99%, 2.6 kilometers can be achieved in 99% of the time and 5 gigabit, while we will also maintain the link up 99.99% of the time. So the 0.9% of the time is when you will not have the complete 5 gigabit at your disposal. Somebody is asking again a question about the installation. So I'm going to go back to the slides. 1 second, please. Okay, so here we have a typical installation of an ODU near an Ethernet switch. Again, can be an aggregation or edge device. It does not really matter. We have the traffic coming from the cloud on the left all the way to the edge device. It doesn't matter at which speed it comes. The edge device has to be connected to the ODU with a copper cable for the management and a fiber cable for the 5 gigabit full duplex traffic. The copper cable can be used for management, as I said, as well as for power over Ethernet in 45 watts. Power can also be delivered to the ODU with a direct DC input. The same setup of the minimum two cables between the Ethernet device and the ODU is repeated on the two sides of the link. I hope this clarifies now the configuration. A question here comes out asking whether it is possible to use two links in parallel between two Cisco boxes and create a 10 gigabit link between the two switches. Yes, it should be possible. You can use then any port channel or link aggregation mechanism available on the Cisco boxes to realize 10 gigabit links through a 10 gigabit link between the two Cisco boxes via two links of EH5500 in parallel, either using two different channels or using one channel and two different polarities on between the two links. In case a question about what happens during a rainstorm or similar events, the modulation will change down from QAM to QPSK or BPSK depending on the intensity of the rain. This will obviously lower the throughput since we do not change the channel bandwidth and we maintain the 1250. So we have a slide somewhere which is going to show this. Let me see if I can get to it. So you can see here on the right of the screen the modulation table and the bitrate, and basically we go down from QAM to BPSK, and the resulting bitrate on the link is affected accordingly. There are still a few questions coming in. Does the 5500 share the same software as we have on our other radios? The answer is yes. The latest software available from Siklu is release 7.2, and the EH5500 will ship out with 7.2 software as well. So anything that your staff knows about managing, deploying, configuring, and upgrading Siklu radios will remain the same, basically. Same 7.2 software, which is currently available for all our platforms, will be available there as well. Okay, I see that there are no more questions coming in. I apologize if I missed one or two questions earlier. Quite a few of them came at the same time, and I might have, as I missed a few of them during the call today, but all the questions are logged on our GoToWebinar, and I will browse through the list of the questions again tomorrow, and we'll try to provide you one-on-one answers on all this. I want to thank you for listening in, and I hope you have learned what you expected to learn from this webinar. I hope to meet you all again soon on other webinar talking about new products. Thank you very much and have a very nice day. Bye-bye now.